Alright, our objective today says I will be able to analyze and compare statistical graphs. I will be able to analyze and compare statistical graphs using bar graphs, line graphs, circle graphs, and stem and leaf plots. I am hoping that you have seen a lot of these types of graphs before, but if not, we will do a quick review. First thing we are looking at is a bar graph. A bar graph can use vertical and horizontal bars to represent data. So here are some horizontal bars. It says that this graph asks students to name their favorite pet, and the results are shown here. Part A says what information is shown on the vertical axis. The vertical axis is your up and down axis. This is your vertical axis. So, vertical axis shows the type of pets. So write that down. Vertical axis shows type of pets. Let's write the vertical axis shows type of pets, and the horizontal axis is your left and right axis. This is your horizontal axis, and the horizontal axis shows the number of students. So your vertical axis shows the type of pets, and the horizontal axis shows, boy, that is some sloppy handwriting, shows the number of students. Just listen to the words that I say if you can't read them. Shows the number of students. So, number of students, types of pets. Use the graph to complete the table. Here's the different types of pets. It wants to know the number of students. So let's look at dog. Number of people who said that they like dog is a little bit over 150. Looks like about 160. All you've got to do is follow this axis, the x-axis, up to figure out the number. So right there, looks like a little more than 150, so 160. The number of people that liked cats looks like about 80 or 90. Oh no, not 80 or 90. 80 or 90 if it was right here. This looks like it's in between 100 and 150, closest to 150, so it looks like about 140. So the number of people that like cats is about 140. Number of people that like birds looks like it's about 40. Number of people that like hamsters, in between 50 and 100. It's right here. In between 50 and 100 looks like a little closer to 50 than it is to 100, so probably around 70. And then the number of people that like fish looks close to 100, not quite there, looks like about 90. So all we're doing is reading that graph and getting the information from it. Next thing it says in part C, how many students were surveyed? Well, to figure that out, I've got to figure out, well, add up all of the people who said that they liked all these different animals. So add up the number that said they like dog, cat, bird, hamster, and fish. So that's just going to be 160 plus 140 plus 40 plus 70 plus 90. Add all those together, I get 500. So 500 students. 500 students were surveyed. And which pet did students choose twice as often as the hamster? So we've got to look at the hamster. Okay. Hamster is 70. Okay. Twice means you multiply that number by 2. So which pet did students choose twice as often? 70 times 2 gives me 140. I look to see how many, or which one occurred 140 times, and that was cat. So let's go with students chose cats twice as often as hamsters. So students chose cats twice as often as hamsters. On the back. Double bar graph. The first one that we just looked at was a single bar graph. A double bar graph shows groups with 2 bars side by side, which allows you to easily compare 2 data sets. This is a graph of Hal and Harry both own sandwich shops. The double bar graph shows the number of shops they owned at the end of the year, which conclusions can be made from the graph. So there's a lot of different things that you could make from the graph. You can compare Harry and Sal. You can quickly and easily compare the number of sandwich shops that they own. What I see is in each one of these, Harry's bar is higher, except for in the year 2004. In each one of these, the second bar, or Harry's bar, is higher. So that means in each year, this is just one conclusion that can be drawn. In each year, Harry owned more shops than Hal, except in the year that they owned the same, which was 2004. Except in 2004, when they owned the same amount. So, what I did in each year, make sure you write that down. In each year, Harry owned more shops than Hal, except in 2004 when they owned the same amount. I just looked at the graph and I figured out the amount of shops that each one of them owned by comparing the two of them. So that's one conclusion I could draw. Another thing I noticed is that in each year, Harry's bar goes up. In each year, from 2001, it goes up. From 2001 to 2002, it goes up. Then it goes up again. Then it goes up again. I'm looking at this one. It goes up, 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 up. So that's another conclusion I could draw. I won't write that down, but the number of shops Harry owns increased from 2001 to 2006. So that's another conclusion I could draw. If it asks you to draw a conclusion, just look at the graph, figure out what sort of information you could see. Last thing we're going to do is a stem and leaf plot. A stem and leaf plot is a data display that uses some digits as stems and others as leaves. The stems have a greater place value than the leaves. Stem and leaf plots are useful for organizing and ordering data. Remember that. The stems have a greater place value than the leaves. So this stem and leaf plot shows the ages of members of a hiking club. We want to find the age at the hiking club that occurs the most often. So, the way this works, 1, 0, that age would be 10. 1, 0, 10. 1, 7, 17. 24, 26, 41, 41, 41, 46. I'm just matching the stem with the leaf. Each one of these leaves in this column right here, excuse me, in this row right here, is matched with this stem. Okay? This would be 41, 41. That should be a 43, not a 46. 43. Here we've got 53, 56, 56, 59. I'm just matching the stem with each one of these leaves. Now all I have to do is figure out which one of these occurs the most often. I see 41 occurs 1, 2, 3 times. So, 41 is the age that occurs most often. Box that in. That is all for this lesson. Oh wait, hang on. Now, that is all for this lesson.